Let's take a trip to the Mars Innovation Workshop, this week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. This week, we're bringing you along for the ride as we explore some of the most exciting ideas from the recent Mars Innovation Workshop, a gathering where innovators, scientists, and engineers came together to tackle the biggest challenges in our future on Mars. Matt Kaplan, our senior communications advisor, attended the event in February and will share some of his conversations from the workshop. Then we'll check in with our Director of Government Relations, Jack Corelli, for a space policy update. We spoke last week about the uncertain future of funding for NASA's Science Mission Directorate. We'll keep you informed with more regular updates about space policy as we work together to advocate for the future of space science and exploration. All that, plus a look at some of our chief scientists' favorite innovations in the history of Martian exploration, as Bruce Betts joins us for this week's installment of What's Up. If you love Planetary Radio and want to stay informed about the latest discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Before we dive into today's main topic, I want to share two exciting opportunities to join us in person for upcoming Planetary Society events in the United States. Next Monday, March 24th, Casey Dreyer, our Chief of Space Policy, and I will be hosting Planetary Radio Live, the future of space politics. That will be held at Johns Hopkins University Bloomberg Center in Washington, D.C. We'll be joined by an amazing lineup of guests, including Bill Nye, CEO of the Planetary Society, Zibby Turtle, who's the principal investigator of the Dragonfly mission to Saturn's moon Titan, Representative George Whitesides, who is the co-founder of Yuri's Night, one of the best space parties of the year, and now a U.S. congressman, and Representative Judy Chu, who's the co-chair of the Congressional Planetary Science Caucus. This event is free and open to the public, so if you're in the area, we'd love for you to join us for this important discussion about the future of U.S. space policy. We're also looking forward to the Planetary Society's 45th anniversary celebration, our Cosmic Shores Gala. That will be held on Saturday, April 5th. We'll be gathering aboard the RMS Queen Mary in Long Beach, California, for a beautiful night celebrating space science and exploration, and reflecting on all of the amazing things that space fans around the world have done together through the Planetary Society. We'll have some fantastic guests lined up, and I promise it'll be a night to remember. Plus, thanks to a generous donor, ticket prices have been reduced for everyone attending, including those that have already purchased tickets. I'll put links on this episode page at planetary.org/radio so you can get your tickets. We'll also share highlights from both of these events on upcoming episodes of Planetary Radio so everyone can celebrate with us around the world. Now, let's turn our attention to the Mars Innovation Workshop. Every dollar budgeted for NASA has generated at least $3 in value. Much of this benefit has come from the steady flood of innovations and inventions developed for space that have found a practical use here on Earth. A new wave of startups hopes to ride the accelerating expansion of commercial space to profitability, and while they're at it, improve the lives of millions or even billions of Earthlings. But the road to success is a bumpy one. There's so much more to it than just perfecting your widget, software, or custom-designed microorganism. Getting a handle on this challenge is why my colleague, former Planetary Radio host Matt Kaplan, recently joined a 2-day gathering of scientists, engineers, entrepreneurs, and innovators.
The Mars Innovation Workshop. That intriguing title was enough to make me sign up and then fly up in early February to the headquarters of the SETI Institute in Mountain View, California. SETI hosted the workshop but didn't produce it. That fell to Explore Mars, the organization that each year also creates the Humans to Mars Summit in Washington, D.C., the event I've been attending and hosting the live stream of for many years. And the genius behind the workshop was also an incentive to attend. Tiffany Vora is a molecular biologist and biotechnologist who not long ago became the Explore Mars Vice President for Innovation. I knew she'd put together a great experience. Here's how it started.
Welcome to the Mars Innovation Workshop. Makers, doers, dreamers, builders, anyone who is interested in building for a better future, that's what we're doing here. And one of our big goals is to expand the space community, to welcome more folks who think that maybe they don't think they're working in space today, but maybe in 20 years or 30 years, their business is actually a space business. So we're really keen on growing things that way. We are here today laying a lot of the groundwork for that by thinking through what are the technology spaces that we need. Let's assume the rockets work. What do we need to have a sustainable and thriving human presence on Mars? And how can that innovation deliver value here on Earth, right? You've probably all heard me say my not so secret life quest is to never again have to answer the question, why should we spend money on space when we have so many problems here on Earth? I don't ever want to answer that question again. Maybe you don't either. So we're going to spend the next 2 days working on the things, the reasons why we believe that's true. And that will also be putting a lot of arrows in our quiver so that when we go back out into the world to talk about how awesome space is, we have all these ideas from the next 2 days about why innovating for space makes life better on Earth.
I quickly learned that the workshop was not exactly what I expected it would be. Sure, we heard about new and exciting technologies, but the focus was more about how innovation is accomplished and encouraged, how much it depends on collaboration and partnerships across disciplines and organizations, and how innovating for Mars benefits us back here on Earth. I was also pleasantly surprised to see the enormous professional diversity of workshop participants, including innovators who were relatively new to the space sector and others who have been expanding the boundaries of exploration and innovation for years. Among this latter group were some old friends. Here's one of them introducing herself and her goal.
Good morning, everyone. I'm Pavia Lal. I used to be the Associate Administrator at NASA for Technology Policy and Strategy. I was also the Chief Technologist there and a Chief of Staff. I want to bring the solar system into our economic sphere.
Pavia visited with me during a break in the workshop action. I will say something to you that I told you yesterday with an apology. I wish you were still helping to run the agency for our sake, maybe not for yours.
I really miss being at NASA, and I wish I were there myself. I think it's an exciting time, it's a troubling time, it's a nerve-wracking time, and we need a lot of stability, yes.
You're with, or affiliated with, or consulting with one of the national labs now?
Yes, so I am actually working with Idaho National Lab to develop a national strategy for space, nuclear power, and propulsion. And I'm just having a ball learning and reading and writing and learning about actually this whole new community of space nuclear that has opened up in recent years, commercial space nuclear.
And this is your field, right? I mean, this must be especially exciting to see. I mean, because there were decades when it was no man's land, no person's, no human's land. We couldn't go there.
I was an undergrad and a grad student. I did my dissertation, my research, and looking at what you do with waste nuclear fuel, nuclear waste into fusion reactors. So I've looked both at fission and fusion systems, and excitingly enough, there's commercial firms doing both fusion and fission today. It's very exciting.
And of course, we're talking about innovation when we talk about these things, which is what this is supposedly about. Although it's this workshop, to see if you agree with my interpretation, is less about here are the innovations we need than here's how innovation takes place.
Yes, and actually I think what's really exciting about this workshop is it isn't just space people. It's like actual architects, not just, space architecture, which is kind of what we know. So the ideas that I'm hearing are not ideas I hear in, space circles, which is very cool. And that's actually the one reason. I mean, I didn't know it when I came, but, 2 days in, I'm really glad I came because I learned, it stretched my mind, and that's a good thing.
Which is always a good thing,
yes.
Yeah. There's another agency which I have had a long affection for, which you also have a lot to do with, NIAC, NASA Innovative Advanced Concepts.
Yes, NIAC is one of my favorite programs at NASA. It has some of the most exciting research that we have seen. I would like to see NIAC be a bigger part of NASA. I would like to see NIAC better connected within NASA, outside NASA. And again, I mean, this is the theme in my head. With the growth of a commercial space sector, NIAC no longer just has NASA as its customer, or where technologies get adopted. NIAC technologies can now go outside of NASA to all of these commercial companies that are looking not just at performance innovation, but cost innovation. And so I'm really keen to see NIAC be better connected with the outside world.
What about just the role of NASA as a pathway to innovation across an entire spectrum of disciplines and what's going to be needed, not just in space, but those wonderful spin-offs that we benefit from here on Earth?
I think we need a lot of flexibility in the way we think about innovation in the space context, and we need to be thinking about on-ramps and off-ramps. I think in the past we could make a monolithic long-term strategy, and we would have, it's today, 20 years from now, we'll have X, Y, Z, here are the milestones, here are the things that we want to have seen done. But I think now we need to have a lot more flexibility because there's innovations coming in from other domains, like IT, the world of AI, quantum, all of those areas. But there's, like you mentioned, there's also off ramps. So a technology developed in the space sector maybe doesn't have the strongest connection in space, can off ramp it to a different sector. So I think these cross connections are really important, and we don't really know how to make them happen other than serendipity. And I wish there were more institutional ways to make it happen, and I don't know how to make that happen yet, but I'm thinking about it.
Let us know when you come up with the answer, the solution for that.
Yes, the answer is 49.
Thank you again.
It's always so awesome to talk to you, Matt. I mean, just talking to you is stretches my mind, so thank you.
Young and very passionate principals in a variety of space-focused startups were a large portion of the workshop attendees. Their enthusiasm for their innovations and for the progress they may generate was infectious. Here are a couple of them sharing their dreams of the Moon, Mars, and beyond.
Hi, I'm Alex Gilbert. I'm the Director of Space and Planetary Regulation at Zeno Power, which is a commercial nuclear startup. I'm also a PhD student at the Colorado School of Mines.
And here I was going to go looking for you, and you walked up to me, so thank you for seeking me out, Alex. Listening to you and your participation in the discussion we just had, which a lot of it had to do with what's holding back the innovations that this workshop is all about. First, start by talking about the things that you're developing, these sources of power that we're going to need for all kinds of purposes all over space.
Zeno Power develops radioisotope power systems. You might be familiar with these from what we use for NASA missions, the plutonium-238 radioisotope thermoelectric generators, RTGs. We've used those throughout the entire space age, and they're on some of the most famous space missions, the Apollo missions, the Mars rovers, New Horizons, Pioneer, Voyager, because they allow us to have power independent of the sun. The problem is that plutonium-238 is plutonium. It's relatively limited, it's very expensive, and NASA needs to prioritize that for its flagship missions. We're developing technologies using alternative isotopes like strontium-90 and americium-241 for a wide range of space applications. Our vision really is that any mission heading to space, whether it's commercial, whether it's a scientific mission that's a smaller mission, has a radioisotope option. So if you want to go to the lunar surface, you can survive the night on the lunar surface with a small nuclear battery, maybe a dozen kilograms or so. If you want to be able to operate through the lunar night, or maybe go operate in those permanently shadowed regions where all that exciting lunar water ice is, we would be able to provide a power system so you don't need to rely on the sun.
Didn't you love it when the Martian dragged an RTG into the cab of his little Mars rover so that he could stay warm?
Oh, we have a life-size cutout of Mark Watney in our office.
I think it was you who made the point that unless you're in launch, unless you're building or hoping to build launch vehicles, it's tough to find investment. It's tough to find markets for the kinds of things that you and other developers across all kinds of technologies are trying to put together.
Yeah, when you look at the space market, I really think there's two major markets from a commercial perspective. There's launch, and then there's Earth-based services. And those are the markets that we've seen new space go into first and really dominate and change. When you get to a lot of the other new Earth orbit activities, like, say, commercial space stations, or you look really at the moon, where I think there's a lot of interest, that's where it's a much harder case to make. And the hope, I think, is what's happening with the moon is really unprecedented. You have all of NASA aligned behind it. You have commercial interests aligned behind it. You have geopolitical interests behind it as well. And you also have a lot of foreign space agencies that now might be able to access the moon for the first time. So that's hopefully creating the critical mass so we can start developing a lunar market. But when you go to investors, they have to believe that that lunar market can happen in order to actually make that visible. So it's a chicken and egg problem. We're hopefully on the point of having enough money going for it with what NASA's doing, with what some of the big new space companies are doing to break that problem. But it's definitely a huge investment challenge to be able to make sure we can do what we want to do on the moon and beyond.
One of the major points we heard from several people was about looking for those terrestrial applications which may develop or may turn into, or at least offer, much more near-term profit than some of these things that we hope are going to happen in space. Now that seems, the work that you guys are doing, seems to have potential there if we can discount everybody's, not everybody's, horrible fear of, anything that's nuclear has got to be evil.
I would say more broadly that when you look at the space nuclear sector, we've seen a lot of interest from the federal government and from commercial entities to develop it, both for radioisotopes and for fission, in large part because we've seen major changes on the terrestrial side. So there's now increased focus on developing nuclear energy for climate mitigation purposes in the United States, or energy security. So that's leading to a lot of opportunities to develop space technologies aside that. From Xeno's perspective, one of the biggest things that we want to develop are these radioisotope power systems for any application where you're going to be remote in a very challenging environment. So there are plenty of applications in the Arctic where you don't have sunlight. One that we look at a lot is deep sea activities. And so if you're looking at oceanography or offshore energy production, potentially in the long-term deep sea mining, those are areas where you don't have the power that you need to do really important things. And so we can be enabling, and you're able to then add multiple markets together to be able to build an investment case, but also you get technology synergies. You can start getting to economies of scale and bringing down your costs across all of the market verticals.
There's so many other people that we're hearing from here who are in these startups like you are. And I wonder if that makes attending something like this more interesting, more exciting for you.
Very much so. So I had the opportunity to talk to some of the original space mining companies and some of the people that work there. And it's, in just 10 years, very different environment than what they had. They were essentially out in the wilderness, that they had to do everything themselves. They had to in-house everything. Now we have a very large, diverse, and growing ecosystem of startups, or people that want to do interesting things in space, but also do things that are valuable on Earth as well. And so that's very encouraging. It also allows us to have a lot more ideas and potentially synergies.
Sounds like you're throwing some respect toward those early companies, which are pretty much out of the business now. They just got into it too early. And really, who realized how difficult this was going to be? We all know space is hard. It turned out to be even harder. But do you look to them as being the pioneers, as the ones who help clear the road or start to pave the road for folks like you?
Absolutely. The reason that I decided to transition from the energy sector to the space sector was because of Deep Space Industries and Planetary Resources. I was very inspired by what they did. They're tackling a very challenging, a very big problem. But when you look, they really were, I think, inspirational for many people. My PhD program started very shortly after those companies were founded. And if you look, I think, even more broadly, they've seeded a lot of the things that are happening today in terms of ambitions for the moon. If you want to go to the regulatory side, they did some of the initial work to make sure that we can start developing a commercial regulatory system in place. Even now, we're working through a lot of the legislative proposals that were started by them, and that's going to be very enabling for us to be able to do our big private sector ambitions in space.
Alex, I wish you great success in all of this as you do your own pioneering.
Thank you so much, Matt.
I'm Erica De Benedictis. I'm the CEO of Pioneer Labs.
Tell me about your company.
Pioneer is trying to engineer the first microbes people will use on Mars. Step one, what are the microbes that we would use indoors for doing useful stuff, making food, bioplastic building materials, water purification, that sort of thing. Long term, how do we actually make organisms that thrive in Martian dirt, in greenhouses or beyond?
Something that eats perchlorate, I hope.
Ideally, you'd be able to remediate perchlorate, make the dirt less toxic to humans. Perchlorate is also not great for microbes, so that's kind of the news from the lab. The more Mars dirt we add, the less the microbes grow, and that's the challenge. So my research background was doing directed evolution and synthetic biology, and so I'm trying to figure out how to take the wide diversity of extremophile microbes we have on Earth and sort of mix and match properties from them in order to create one organism that can actually tolerate the plethora of stressors that you would face as a microbe on Mars.
Is this work that could have been done or in any kind of practical way 20 years ago?
This work benefits enormously from modern advances in synthetic biology. Even 5 years ago, it was way harder to do genetics in non-model microbes. So anything that wasn't E. coli or something like super commonly used, we just didn't really have the tools to alter its genetics in ways that are super valuable for engineering, because we can actually go in there, look at the genes, and make some rational decisions about what new genetic material might actually help a microbe. And that's something we can uniquely do now. That said, there are some really cool papers from the 70s where people sort of did some early attempts to evolve microbes toward unusual conditions. There was one crazy study I found where people tried to evolve algae to grow in heavy water, not a Mars stressor, but certainly a sort of extraterrestrial type environment that you might find elsewhere. We have a much better chance today of solving the problem than we used to.
Why do all of these things that you've talked about may be possible using biology rather than machines?
We certainly could use machines for a lot of this, and I think my curiosity is how we can better leverage biology to do it. Historically, humanity has benefited a ton from living on a planet that has this thriving biosphere that gives us all of the essentials. So we get food and air and water and building materials. We make log cabins out of biology, right? And that has sort of traditionally been what the frontiers of human civilization reaches for. You have to go somewhere and discover how to make use of the nature around you, including everything that's alive. And so I would love to live on Mars if it's a garden. I'm not so sure if it looks like a space station, if I'm even interested, right? Not to mention the fact that biology can do all of these things. So sort of why reinvent the wheel with chemistry?
And have to have all those spare parts on hand for the machine.
So many spare parts. Very brittle, right? If your chemistry machine breaks, you're out of luck. If the weather changes and suddenly the environment's a little different and you rely on microbes, they'll just evolve, right? So it's a much more resilient type of technology to sort of bring with you somewhere where you're not sure what will happen and you want to guarantee resilience.
So much of this workshop is about not just the technology, the technological challenges that you're talking about, but the business challenges, which is, I think, something that you're probably dealing with on a daily basis.
The blessing and the curse of space science right now is that things are starting to happen and haven't finished. We're still in this massive bootstrap to having there be some sort of customer actually living in space. And I think everyone who's a space enthusiast can imagine that future, but it's a tough, long road to get there. And a lot of technology development needs to be done in order to enable the presence of a customer that would justify the technology. And that's the fundamental bootstrap. But I like that. I'm a scientist. I like being at the beginning of things, and that feels like what's happening to me. It's really cool to see the stuff happening in private space now. It's sort of cooking with gas in a way that it didn't used to be, which is really exciting.
So the other part of this that we're focusing on here is these technologies that are promising for Mars offer promise on Earth as well, and perhaps profit in the shorter term than what you might achieve on Mars.
Absolutely. That's something I think about a lot. Fundamentally, the challenge on Mars for biomanufacturing is you want to make use of the materials you have on hand. So you want to upcycle everything.
In situ.
In situ. Every raw material or waste stream you have, you want to be able to use biology to convert it into something higher value. And terrestrially, that's what green technology is. And we have terrestrially struggled to do that because waste streams, they tend to be variable, or they're not as rich as just pure sugar water, which is the alternative that's the alternative that people more regularly use to feed microbes. And so if we're able to solve this sort of circular economy in a space science context, that's immediately applicable on Earth. And it would make everything in biomanufacturing cheaper if we were able to have the input to that system be something very low cost, like a waste stream.
You already said a little bit about this, but talk more about your personal motivation for work in this area.
I have like 5 reasons. Space is a application area that hands you this blank slate. There are no excuses in space for continuing to use technologies that we now know aren't sustainable or are only around because we have centuries of investment in like entrenched infrastructure that we can't justify upgrading, right? In space, there's nothing. And so you have this opportunity on a silver platter to just do it right the first time. That's why I like space. It's a area where people get to be very creative with the technologies they're trying and are not so constrained by so many choices that were made by people who came before us.
Which sounds like something that could provide a lot of incentive to somebody who wants to achieve these things.
Yeah, totally. It's a great sort of like first market. I think a lot about how to create scenarios where scientists have the freedom to be creative, and a great recipe for that is displaying to them a problem they've already thought about a million times, but in a different context with a different set of constraints. That's space science. It's all of these same sustainability, manufacturing, like human civilization issues, but with like every single constraint is tweaked. And so you have this wonderful, like essentially brainstorming prompt for creativity and like new solutions that if you go down the path and develop it, of course you can use it elsewhere too. It's the same fundamental problem.
Sounds almost like space as a powerful growth medium for ideas rather than just living things.
Yeah, that is a great way to say it. I love that a lot, actually. Yeah.
You can use it.
Thank you. I'll steal it.
I was also delighted to see old friend Chris McKay at the workshop. He was one of the founders of the informal grassroots group of scientists who called themselves the Mars Underground. That was over 40 years ago. Chris would also help to found and expand the field of astrobiology, and that discipline is still what dominates much of his work at the NASA Ames Research Center, not far from where the workshop was underway. Chris McKay, it's been a while.
Yeah, it's been a long time.
You brought up this possibility of thinking of the developments that have been taking place in Antarctica and how Antarctica has been opening up as an analog for what could happen in space, or at least in low Earth orbit.
50 years ago, when I first went to Antarctica, it was only science bases, only government-run operations focused on science. Now, there's huge infrastructure, there's landing strips, there's more tourists in Antarctica each year than there are scientists. How did that happen? Well, it happened very small with one ship, ice-reinforced ship, kind of pioneering the idea of tourism, and then it just grew. And there's an enormous demand. As you might imagine, it's quite expensive. And I think that its trajectory from small, one ship first, now to an infrastructure that supports tourists, permanent bases, the whole thing, is a trajectory that could be followed in space. The scale is higher, cost-wise, but that will come down just like it did in Antarctica. It's a lot cheaper to go to Antarctica now than it was on that first ice-reinforced vessel. But there's certainly demand, and if the cost can be brought down reasonably, I think people will line up to go. There's a tendency to think that space has either got to be only for scientists or it's got to be for companies making money. But what about tourists? What about people who just want to see what it's like for a couple weeks or a week? That's been a big factor in Antarctica, and I think it could be a big factor here. As a scientist who works in Antarctica, I benefited from that. I am now sending equipment down to bases that are run for tourists and having science done from that base is much easier and much cheaper than doing it the other way around.
And I'm sure you're not alone. I mean, one of our board members, Brittany Schmidt, is down there all the time, and I'm sure she's benefited from this as well. We should bring it back to the Red Planet because this is, after all, the Mars Innovation Workshop. I don't know if there are any people who've been actively Martians much longer than you've been. I already apologized to you when you were introducing yourself. I did that shout out to the Mars Underground, which you were a member of, right?
And this is it now. This is it now, really.
Uh-huh.
It continues. The idea that this is a bottom-up thing, and let's push from the bottom if it's not being pulled from the top, is a valid social engineering logic, and I think it applies still. Yeah, hooray for that. And that's why I came here, is to see, what's the Mars Underground doing these days.
What does this workshop or anything else that's going on say to you about the progress that has been made since you and a few others decided we're going to work from the bottom up to get us to Mars?
There's been progress. If someone had asked me 50 years ago how much progress would there be, I probably would have said, I hope there's a lot more than what we've seen, but still it's progress. And it's great to see this kind of enthusiasm. It's just a matter of time, really. Mars is there, the moon is there, the solar system's there, the stars are there eventually. It's just a matter of time.
I love that. I got to go back to your day job. What's happening in the worlds of life as we know it and life as we don't know it?
Well, still trying to get life detection missions going. And there's really good targets out there. There's Mars, of course, ancient life, maybe life there now. There's Europa, thick ice cover, but somehow we'll get through it. Enceladus, with moon of Saturn, with a vent coming out from what's clearly a habitable ocean. Wow, that is just so amazing. And samples coming out free, just go through and grab one. Right. And Titan presenting a really interesting world with a liquid that's not water and possibilities of maybe finding life, but not as we know it, Jim.
We've got a Clipper on its way, at least.
Clipper's on its way to Europa, and it's got instruments that could, in principle, detect molecules that would be pretty interesting evidence of something biological.
Your passion seems to be as great as ever for this line of work.
Yeah, well, it hasn't diminished, and working at NASA for 42 years now, it's been great, and I'm still there and I'm still going. So and it's good to see folks like this coming up and being interested and taking new approaches. So hooray for that.
I'll let you go talk to some of them. Thanks, Chris.
Okay. Thanks, Matt. It's really great to see you again.
You too.
We'll be right back after this short break.
Hi, y'all. LeVar Burton here. Through my roles on Star Trek and Reading Rainbow, I have seen generations of curious minds inspired by the strange new worlds explored in books and on television. I know how important it is to encourage that curiosity in a young explorer's life. That's why I'm excited to share with you a new program from my friends at the Planetary Society. It's called the Planetary Academy, and anyone can join. Designed for ages 5 through 9 by Bill Nye and the curriculum experts at the Planetary Society, the Planetary Academy is a special membership subscription for kids and families who love space. Members get quarterly mailed packages that take them on learning adventures through the many worlds of our solar system and beyond. Each package includes images and factoids, hands-on activities, experiments and games, and special surprises. A lifelong passion for space, science, and discovery starts when we're young. Give the gift of the cosmos to the explorer in your life.
After 2 very full days following tabletop group exercises, panel discussions, a great tour of the SETI Institute and a presentation by its leader, Bill Diamond, live interaction with a group of innovators in Saudi Arabia, and, not least, a lot of laughter, I asked workshop leader Tiffany Vora to review what had been accomplished. Tiffany, great job. I'm so impressed with how you put all of this together. Great thought behind it, and great fun, which I assume was part of your intent.
It was absolutely part of the intent was to have fun. So one of the first design principles that I brought to this workshop was no sage on stage, no slides, nothing that could be approximated with a YouTube video. Everything else we did, we tried to make it as hands-on as possible, getting people talking to each other, working with each other, arguing with each other, laughing with each other. That was all what I was really hoping to achieve, and I'm so pleased that these participants really came with their A game. One of the things that I love so much about the space community is just how generous people are. Even when they're arguing and disagreeing and all of these things, people show up for each other in a way that I think is really exciting. And that's why I'm excited to expand that space community, because the more generous hearts and minds and hands we have in the world, the more likely we are to do this.
What do you hope people are leaving with? I mean, we heard some people make some wonderful, very generous offers of how they say that they might be able to help other folks, even people who want to begin a startup.
I was hoping really for relationships and potential collaboration seeding. So now we have a whole series of capabilities in this room and people who know each other. Social capital is really important in this world because it's such a noisy world. Now we've got a group of 40 people who, if I call them, they'll pick up the phone, and if they'll call me, I'll pick up. And that's exactly what we want. This is how we get things done. We like to believe that everything is based on merit, and stuff still has to work, but honestly, who you know really matters, and who says yes to you really matters. I'm trying to grow into a person in this world who says yes, and now we have a whole new set of people who are willing to say yes to each other.
You're still fairly new in this position as Vice President for Innovation, right, at Explore Mars, the sponsoring organization here. I don't know if this was the start, but if it was, pretty good start.
Thank you for that. I'm lucky in that I've spent the last, let's see, how old am I? I've spent the last 10, 12 years working in the innovation ecosystem. And so this type of workshop where we all set down what we're doing and try something different is something that I've done before. I've never done it fully for just the space community, or I'm making air quotes, which of course no one can see, but with space as the nucleus. I'm a molecular biologist by training, so I've done it for biotech, I've done it for lots of types of exponential technologies. This was something I was really excited to do because to me space is by its very nature interdisciplinary. So what happens when we get doctors and lawyers and engineers and builders and rocket people and put them together and say, okay, now work on something you don't know anything about. And that is a really hard thing to do because we have to let go of the way our minds and our habits usually are. So you might have noticed two of the sessions that we did during this workshop, no solutions were allowed, none. And even as the facilitator, it was really hard for me to not just say the answer, right? But if I'm struggling with it, then our participants are struggling with it too. But what we did was we held that space to force ourselves to say, no solutions, spend time on the problems. I think that's really valuable today because our world is so fast-paced. To actually get to slow down for a couple of days is really valuable.
Knowing that you are nothing if not a multitasker, I still want to know what else is going on. What's up next for you?
Gosh, so with Explore Mars, we have our big conference, our summit coming up in May, which is always very exciting. Happy to get excited about that.
Humans to Mars, but it's now Humans to Moon and Mars.
That's right, Humans to Moon and Mars, H2M2, which is exciting, a little controversial in the community, but it's really important because now we're moving into the Artemis years, right? And to me, this is what's so exciting about being in this moment. It's happening now, right? It's really happening. And I'm just so excited to be part of that wave that is going to be pushed into that future. I think it's fantastic. Other things that I work on, so I'm a molecular biologist by training, so I work with other organizations and communities looking at the future of biotech and how that can help with health and food and various other energy, all these materials, all these different verticals. That's kind of my home zone, so that's really great for me. I've got a couple of things in the works there. And I have recently launched my Substack, which is called Be Voracious, so come find me on Substack, Tiffany J. Vora. And all of that is in service
service of the book that I'm writing, the things that we can learn from looking to the natural world and nature's 4 billion years of innovation on Earth. So I'm doing all the things at the same time, but really what I try to do is make them feed each other rather than have them be distractions from each other. I have a very specific vision of the future, and I have a way that I want to show up in the world, and all of these different things are a realization of those.
You can follow Tiffany on her new Substack, Be Voracious. My thanks go to Tiffany, to Explore Mars CEO Chris Carberry, and to the SETI Institute for making the workshop happen and letting me attend. For Planetary Radio, I'm Matt Kaplan of the Planetary Society. Ad Aries.
Thanks, Matt. It's always inspiring to hear from people working at the cutting edge of space innovation. But while some are looking toward the future of space exploration, others are fighting to ensure that exploration has a future at all. Big changes could be coming for NASA. Over the past weeks, reports have surfaced about potential deep cuts to the agency's science budget. Cuts that, if enacted, could have a devastating impact on space exploration and planetary science. While nothing's set in stone yet, now is the time to pay close attention. That's why we're kicking off a more frequent series of Planetary Radio space policy updates. As these budget discussions unfold in Washington, we'll be here to break down what's happening, why it matters, and how you can take action. To help us navigate the latest developments, I'm joined once again by Jack Corelli, our Director of Government Relations, reporting in from the U.S. Capitol. Hey, Jack, welcome back.
Hey, Sarah. Good to be here.
It's going to be great to get you and Casey onto the show on a more regular cadence to discuss what's going on with NASA during these times. I know it's a lot of space policy updates, but now uniquely is the time when I really want to hear what's going on week by week. So I appreciate your time.
Absolutely. This is one of those, we've been talking about this. This is one of those moments we were made for. So really happy to be able to jump on and give you and the folks listening an update on what's happening here in Washington.
So what went down this week?
So it's been kind of a crazy week. if you've been paying attention on social media, maybe you saw some news, but for those that haven't, or I guess a recap of what happened earlier this week, it was announced that Acting Administrator Janet Petro, who has been in that role since the inauguration of the current administration, announced the closing of the Office of the Chief Scientist, the Office of Technology, Policy, and Strategy, and NASA's Diversity, Equity, Inclusion, and Accessibility branch of their Office of Diversity and Equal Opportunity. And so with that is laying off, I think, a little bit more than 24 people in the NASA ecosystem, and that includes the chief scientist, as well as the head of the OTPS, which is, I will note, different from OSTP, which is a White House office that also does science and technology policy.
Not confusing at all.
Not confusing at all. There, OSTP, that's like federal government wide. This OTPS is within NASA exclusively. And so obviously removing the head of that office, as well as the support staff and the chief technologist and chief economist for the agency. And so all of those roles, which currently serve in a more advisory role. So for example, like the chief scientist is not the person in charge of the Science Mission Directorate, but all of these folks that have recently been told that the end of this month is going to be their last day, are people that provide an advisory role in coordinating strategies and providing analysis and detailed memos to folks within NASA so that the efforts across this sweeping agency can be coordinated in some way.
This is a challenging place to be in because we saw just, what was it, last month, them basically deactivate all of the advisory groups that oversee all the different things going on at NASA. So effectively, we've kind of taken out these advisory roles, and now each of these teams are kind of functioning on their own.
Yeah, and I'll say there's an important distinction between these civil servants who are being laid off and the work that the assessment groups and analysis groups do for NASA, as you mentioned. Both of them, right? They all serve in like sort of that advisory analysis role, these civil servants are like actually in the agency and implementing policies and strategies and like working across different directorates, all the different silos that exist within NASA, from human space flight to the operations of things like the ISS to the Science Mission Directorate, coordinating all of those different efforts. The AGs, as we affectionately call them, the analysis groups, are still stood down. But those are grassroots organizations, right? Those are groups of scientists who are selected or elected. Each one has their own set of bylaws for set terms, and they provide oversight and guidance and sets of recommendations to the agency, non-binding. But it's a symbiotic relationship. It's a way for the administration to have a pulse on what's happening in the community. I'm actually just getting back, as we're recording this, I was on a plane maybe 3 hours ago, on a plane back from Houston, where the Lunar and Planetary Science Conference, LPSC, was taking place. And that was a big question, is like, what is going to happen with these AGs? Because you have things like, the Venus Exploration Analysis Group, who's obviously looking at the Venus missions. We have 3 Venus missions on the docket: Da Vinci, Veritas, and then the European Space Agency mission, Envision. But the AG, the group of people in charge of, or I guess, analyzing those programs and like where the community is heading and the interest, the scientific interest of the community, they have no way to communicate with NASA in that official function through the AGs. And I don't know if it's entirely public yet, but one of the other announcements that's happened recently is in these advisory groups, there's the NAC, the NASA Advisory Council or Committee, is a group of generally aerospace professionals who provide, this is like in a more official sort of advisory role than the AGs, which are, again, a little bit more on the grassroots side. But the NAC is consolidating all of the individual science disciplines. So there was basically a subcommittee focused exclusively on planetary science programs and providing advice and oversight. And then there was an astrophysics one and a heliophysics one. They're merging all of those into one big science subcommittee of the organization. But I think there's been a little bit of pushback from the community because there's not always a lot of there is great overlap between the different science disciplines, but sometimes there's just not the time that you can take, right? What is affecting the planetary science community isn't always the thing affecting the Earth science community. And so it kind of reduces the ability for these people to, provide input and guidance to the agency. A lot of big changes, I think, is at the end of the day, what you can take from my diatribe.
And something that sparked these weekly updates that we're hoping to be doing is the fact that last week we shared that there is this discussion of a potential very massive cut to NASA's budget. And I have heard from some people on this subject that they don't think that this is something they should actually be concerned about. And as we said last week, this is not set in stone yet. This is something that people are talking about in Washington, D.C., but isn't actually on the presidential budget request or anything like that. So what would you say to those people who are skeptical about the fact that we need to be worrying so much about NASA in this moment?
I was also very skeptical of these reports that we heard, I guess not even reports, rumors, right, that we started hearing about 3 weeks ago, that there was a proposal in the works, or at least being discussed, between NASA and the White House. Notably, we have not gone through what is called passback, where the Office of Management and Budget tells NASA, I guess, sort of that next step in the budget request generation process. We have not had that. That is a very important step when the Office of Management and Budget goes to NASA and says, here's what we're able to give you functionally. That has not happened yet, in part because we have yet to pass full year appropriations for FY 2025, which as of recording this is still uncertain. I was really skeptical at first until I started hearing it from more and more people independent of one another. And it's still not pen to paper, this 50% budget cut proposal. All we know is that it has been discussed at some level within the agency and Office of Management and Budget. Whether that is going to be in the president's budget request we're going to have to wait and see. But that is an existential threat to space science at NASA, something that only NASA is capable of doing. There is no commercial alternative to Mars rovers, right? You can't go to Home Depot and pick up a Dragonfly. So it's very important right now to provide input. And hopefully, my hope is that this doesn't come to pass and we can say, great, we're moving on to the next thing. But if there really is a proposal in the works to cut NASA's science funding by 50%, that would represent the largest downturn in NASA's history for its science programs. And I think is, even as a concept, worth taking seriously enough to write your member of Congress and write the administration to say that that is not acceptable. Hopefully, it does not come to pass and we can move on to the next, set of issues, which is, determining where those priorities are in fiscal year 2026. We won't even be able to talk about those individual programs till we have the president's budget request. And even then, if the request is have the budget, the number of problems that causes across the agency and across the Science Mission Directorate, uncountable almost.
The good news is, though, that our members and people all across the United States who are passionate about planetary exploration and space science have actually gone to our Action Center and used our form to write a colossal number of letters to Congress. And last time we checked in last week, it was at 2,000. We gave a little bit of an update in last week's show on the numbers that we were at then, but where are we at now on this Friday, March 14th? Pi Day.
On Pi Day of all days.
Give me a reason to eat pie, Jack.
14,000 letters.
Oh my gosh.
Have been sent to Congress and the administration from people from all 50 states saying that this is not acceptable, that science is an important function of NASA, and regardless of party affiliation or economic standing or demographic information, like people are coming out of the woodwork to be part of this moment to protect NASA science, because it is truly a unique thing that our government has committed itself time and time again and has set up these strategies and processes for determining the next destination and the next slate of missions. And we're able to operate 140 spacecraft either in development or in flight across all the different phases, from pre-phase A to phase E in operation, extended operation in some cases. And it's truly amazing what we are capable of doing. And certainly there is no commercial alternative. There are commercial options for components and for launch vehicles and for parts of this. And it's becoming more and more a collaboration between the private sector and the U.S. government. But the U.S. government is still, even for those private companies, is still that anchor client, right? We just had in this last month a string of multiple lunar landing attempts, which is truly amazing. We have more on the way. The first fully successful with Firefly's Blue Ghost 1, which does have a Planet Vac on it. It's just amazing what NASA is able to do and enable through programs like the Commercial Lunar Payload Service, which is trying to build up that industrial base to allow for there to, at some point in the future, we're talking about time horizons of 5, 10, 15 years, of there being a sustainable lunar economy and sustainable lunar presence, both robotic and crewed. That doesn't happen overnight, and that doesn't happen through concept art. That happens through hard work and dedication, and most importantly, funding.
Well, thanks for the update and good luck in the coming week. I'm sure whatever's going to happen is going to be just as hectic as this week, but it'll be wonderful to see you in the Capitol, and I'm really grateful for your time. So we'll hear again from you next week.
Yep, sounds good. Thank you, Sarah.
Now, before we close out our show, let's check in with Dr. Bruce Betts, our chief scientist for What's Up. Hey, Bruce. Got a big old trip coming up to Washington, D.C. in a few days. Also really glad that Matt got to take this trip to the Mars Innovation Workshop. I'm always glad to hear Matt's adventures.
Matt is adventuresome. That boy loves to travel.
Every time I talk to him, it's about some wild new adventure he's been having while he's had less of a burden doing planetary radio. And yet still, he's out there going on adventures like this and giving us good content. But since we're talking about Mars this week, and you've done all kinds of Mars research, I want to put it to you. Like, what are some of your favorite innovations in the history of Mars exploration? And I know that's just a huge question.
There's so much stuff. Let's start on the start on the engineering side. The whole being able to land on Mars pretty consistently for the U.S. has been very impressive. I mean, it was ugly early in the days when other former country was splattering the surface with landers, and JPL and NASA have done quite, and Langley once upon a time have done quite a job. But they use a different technique every time. And the last couple I've just assumed would fail. And Rob Manning and the group at JPL make them work. Airbags. They used airbags and bounced a spacecraft like a kilometer or two in airbags. And then it's like, we need to fly some bigger airbags, won't work anymore. I know, Sky Crane. And Mars is like one of the hardest places to land in the solar system. It's got just the wrong amount of atmosphere. So the fact that they've gotten so successful with that, and the rovers are amazing. And you get into the science instruments, I don't think I can even start because I'd be going for a really long time. But just to watch their progression from the early cameras on orbiters to the advanced, in situ instruments on the landers, or just the orbiters now that have such amazing instruments that we can learn so much from a distance as well. It's amazing.
Well, in the last few weeks, we've done a lot of shows, some of which are very hopeful, some of which are talking about the current moment in space politics and all the difficulties we have ahead of us. But we've been getting such wonderful messages from people online. I wanted to share at least one from Devin O'Rourke from Colorado, who was talking about our episode about Haley Arsenault, who was the first pediatric cancer survivor to go to space. And he said, Plan Red this week was a welcome shot of positivity in a sea of negative and difficult things recently. Highly recommend listening to it if you, like me, need that ray of sunshine. I would love to return to being belligerently, obnoxiously hopeful, as Sarah put it. So thanks to Sarah, Bruce, and the team.
Yeah, that was great, and it is wonderful. And space is a hopeful thing, and it's someplace where we look up and we reach out and we do amazing things and we learn amazing things, and that's always there. Whatever stuff is going on Earth, space is a great. It's just great. So anyway,
what's our random space fact this week?
Random space fact. Let's talk about. I'm coming back to Voyager because Voyager is amazing, and Voyager 1 is now 166 and a half AU from the sun. So 166 times the Earth-Sun distance, and since sunlight goes as the inverse square of the distance, it's using its happy little RTGs that are the power is dropping, but it just couldn't even pretend to play the game with solar panels because it's getting about 1/27,000th the amount of sunlight that we get at Earth. That's about 1/1000% if you prefer to think in those terms. Gosh. It's dark out there.
Yeah, not the place to be if you're afraid of the dark.
I mean, the sun's bright, so the sun's still looking brighter than anything else around, but still.
Seriously.
Robot, not afraid of the dark. Don't worry.
Yeah, it's fine. It's fine, Sarah. They're doing just great. They don't even know.
It's important to try to remember this. It's very easy because they're so freaking cool.
Yeah,
you will set yourself up for a lot of disappointment if you anthropomorphize every spacecraft.
I know, right? I was a mess when Opportunity went down. It's just a rover. Like, just chill out, Sarah. They're on their space adventures, and we're the ones here that get to enjoy all the wonderful science.
Exactly. They are an extension of our humanity, but they are not humanity.
Truth.
Oh, there I go being philosophical again, or not. Everybody go out there, look up the night sky, and think about what type of curtains you'd use if you were in a spacecraft. Or would you have curtains? Do you need curtains? Thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email at planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members who dream of a future of scientific Martian exploration. You can join us at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. And until next week, ad Aries and ad Astra.